Okay, well, to get the turning point, what I would suggest that we do is we get the derivative. Okay, which is 2x minus 2 minus 0. At a turning point, the derivative is 0, so we can solve for x. Bring the negative 2x across, and then divide both sides by negative 2. So x is 1, and then remember the f of 1 is your y value. Plug it into the original, and there we go. And what do we have here? We're going to have here 1 minus 2 minus 8, which is negative 9. So your turning point is at 1, negative 9. Okay, which is great. Okay, that's fine. That's one of the methods that you can use. If you opted to use, say, x is equal to minus b over 2a, then remember that you've got 1x squared minus 2x minus 8. There's your a and your b. So that would be x is minus b all over 2a, which of course is 1. And how do we get the original? By working out the f of 1, which is 1 squared minus 2 times 1 minus 8, which of course is negative 9. And once again, you get your turning point. This is using minus b over 2a. Only for parabolas, though, people. When you get to cubic graphs in the next lesson, you can't use minus b over 2a. But the calculus method is the most popular one for other graphs as well. Okay, so it's very, very important that you do that. If you want to sketch the graph, and if we want to use the method of the x-intercept, well, the y-intercept we know is at negative 8. The turning point is at minus 1. Let's just see that the turning point is 1, negative 9, should I rather say. 1 and, what's it, 1 and, yeah, 1 and negative 9. Cool. Okay, 1 and negative 9, that's your turning point. But the x-intercept, what can we do? We let the y be equal to 0. And look here, then you factorize. You could use the quadratic formula if you so wish. And then we get x is 4, or x equals negative 2. Now the fourth method to get the x of the turning point, you add up the x-intercept and average. Now look at this, 4 minus 2 over 2 is 2 over 2, which once again gives you the 1, and you plug back into the original to get your corresponding y value of negative 9. Now just to look at this graph, we'll sketch it quickly, and let's see how it goes. Okay, there we go, set of axes, and we've got, if we look at this, what would be the turning point is at 1, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it turns there. There's your axis of symmetry. Okay, turning at 1, negative 9. At that point, the gradient is 0. And then your x-intercepts would be at 4 and negative 2. 1, 2, 1, 2, 3, and 4. And negative 1 is there. And we're going to go to negative 2 over there. And then, so it's at that point there, and then 1, 2, 3, 4 there, and cuts the y-axis at negative 8. The parabola would come down. At its turning point, its gradient is 0, and up we go. That's the graph of f. That's minus 2, that's 4, negative 8 there, and that point there is negative 9. So remember, the f of 1 is equal to negative 9. That's the corresponding y value. But the derivative at 1 is 0, because the turning point is where the gradient is stationary, where it's not moving, where the gradient of the tangent line is 0. Okay, so people, master these things. In the next lesson, we're going to be focusing on cubic graphs and showing you exactly what that graph looks like and how to approach it. So stay with us.